Let me show you. This is the first where we have actually two unknowns. And there's sort of a category of two unknown ones where we can solve it without using matrices or systems of equations. This one we can solve because of symmetry. The reason being that if we just draw a line like this, right, it's got bilateral symmetry. So you'll see the equations just sort of fall in our lap. And then there's another one. If you have a special angle, sometimes you can solve it without matrices. Ultimately, we could solve this one and every one of them with matrices, but we don't want to resort to that if we don't have to. So let's just go through this thing. Let's draw pictures with forces as arrows. So we've got the force of the tension like this. All right, you try to draw a straight line. Whoa, there it is, right? And these are the same. I'm going to call that T and T. Because of the symmetry, they are the same force. Okay, calculate the weights. So 5 times 9.81 is equal to 49.05. Right, so that is a downward force on this, right? I'm going to draw it like this. So we have 49.05 newtons down, okay? And then we're going to draw our components, right? So we've got a component like this. We've got a component like this. Got a component like that. And a component like this. And that's 18 degrees. This is also 18 degrees. That's too lazy to label it 18 degrees. All right, so this side right here is, it's the opposite side. So it's T, and we have an unknown. So since we don't know that, we just go T sine 18, right? And then this side here is T cos 18. And this side here is also T cos 18. And then that little side right there is opposite, right? So it's T sine 18. So notice we in the past where we only had one unknown, we were able to calculate it, right? Here we're expressing the component. So when I say express, make it like you have an unknown and just go, okay, hypotenuse is T, so it's T sine whatever, T cos. You'll get used to this, okay? And then let's go back to blue pen land. Can't do it. All right, so this guy is going to be positive, and it's going to be in the x direction. This guy is going to be negative because it's to the left, right? And that's also the x direction. This one's going to be positive in the y direction. This guy's going to be positive and also in the y direction. And then this 49.05 will be negative and in the y direction. Okay, so now we set up our equations. We'll have an x equation and a y equation. The x equation is kind of funny, right? It is like this. It is minus T cos 18 plus, these are the only things in the x direction, right? That guy and that guy, plus T cos 18 equals 0. That is true for all values of t. So this equation is kind of a bust. Okay, so let's look at the y equation, right? The y equation will have this number in it, right, which must be useful for solving this, right? Can't solve it without that mass, right? Okay, so for this one we've got, I've got this guy, this is in the y direction, right? So plus T sine 18, and then I've got minus 49.05, that's this guy, right? And then I've got this guy too, right? So plus T sine 18 adds to 0. Well, this one has got only one unknown, right? Because the t's are the same. These terms can be combined and we can solve this. It has only one unknown. Okay, so let's keep going, right? So 2t sine 18 minus 49.05 is 0, and 2t sine 18 equals 49.05, and finally t is equal to 49.05 divided by 2 sine 18. And now we can solve this. Let's solve this thing. 49.05 divided by parentheses 2 sine 18, right parenthesis. And it's 79.4 newtons. Okay, now the cool thing about this is that this is a very simple mechanical advantage. Notice with the application of 49 newtons of force, we actually generated almost 80 newtons of sideways pulling force, right? If this is your car and you're stuck and you don't have a winch, well, if you've got a chain, you can tie this side to your car and this side to a tree and then just push on the side of it like that. And generate a mechanical advantage. It's kind of the poor man's winch, right? And 18 degrees is a fairly large angle. If you do the same thing, if you go 49.05, and if we tighten it up so that these angles are 5 degrees, so divided by 2 sine 5. If you're 5 degrees, you generate 281 newtons of force. And then just to have fun, if these two angles are 1 degree, they are 1 degree, if you tighten it up that much, right, you generate 1,405 newtons of force, right? If you have something stretchy like a climbing rope, this won't work so well because the climbing ropes are designed to be stretchy, and so if you push on it, it'll move a lot, and the angle will get big, and you won't get that much force. But if you have something like a chain or something like that, there it is, right? Anyway, there you go. So this one we can solve because these t's are the same. Okay. If those angles weren't the same, t's would not be the same, and we couldn't solve it that way. We'd have to use matrices. Okay. All right.